Okay. Annette, doing okay? Doing okay?
It could come from any direction and she wouldn't know who it was.
Well, since you're talking about it right now, I would know that you're throwing.
Also, guess where this shirt came from?
Somewhere that's way too expensive.
I raided Shay's closet yesterday. Also, she has a very.
Landon, let's get started here. Camille, let's get started here. Any homework questions of 2.1? It will be due today. What's the date today? 24th?
Yeah.
Okay, and then 2.2 homework will come together on Friday. We'll have any homework questions from 2.2, and that will be due that Friday evening. We good? So Abe or anybody, give me any homework questions you have.
21, 25, 27, 45, 49, 65, 69, 70.
69. Okay, we'll do a few of each here. So give me the list a little slower. 21, 25.
25, 27. Those are all at one time. And then 49.
49, okay.
And then 65 and 69.
Okay, so let me take a look at it. So 21, 25, 27. Let me see which one would be the best one here.
I tried. The red is stuff that I didn't.
Let's see. Let me do maybe 27 because that'll be the toughest one, and the other one should be pretty easier. Yeah. So let's do 27 for this one. 27. It is this function right here. It is 1/4 in front minus 2x minus 12. That's cool. It says sketch the graph of the quadratic function without having a graphing utility. Find the vertex, find the axis symmetry, find any x-intercepts, and then you go from there. Okay, let's go for it here. So this is in trinomial form, right? Remember, we have two different things. You have standard form, trinomial form. Trinomial form is ax squared plus bx plus c. Standard form is, I'll just put st for standard. Standard form is ax minus h squared plus k, right? So you got those still two forms, so always think about them. So in trinomial form, the vertex, or at least the x value of the vertex, is negative b over 2a. So as long as we solve that, we have the x coordinate of the vertex, and we also have the axis of symmetry. We already know where the middle is going to be of this guy. So let's plug it in. It becomes negative of a negative 2. Dunk, dunk. It's 2, then it's going to be 2 times 1/4. Okay, good there. So negative 2 is a 2. This one, I think I can reduce this, right? 2 and 4 would be reduced down to 1 and a 2. So it's 1/2 here. And then what we do is we change to multiplication by reciprocal. So are we good with 4? 4 being the value for the x coordinate of the vertex. And so we can actually even do this one right here. So the axis of symmetry, I just call it AOS. Axis of symmetry is x is equal to 4. Sweet. Let's jump to get the rest of the vertex. So the way we get the rest of the vertex, the y value for the vertex, is we plug in the 4. So 1/4 times 4 squared minus 2 times 4 minus 12. Dun, dun, dun. That's 16. 16 divided by 4. That's going to be 2 times 4. And eventually, how about 4 minus 8 minus 12? What does that look like? And 16? Awesome. So I'm going to put V for vertex. Vertex is 4 comma negative 16. So at this point, just by knowing that information, I could almost start drawing it here. Only thing that we got to think about is where it hits the, it says the x-intercepts, but you almost want to do the y-intercept too, because that's another point. So if you just want to do the y-intercept really quick here, it's abbreviated as y-int, and that's the easy one. Anybody know what that is? Negative 12. Yeah, negative 12 is just 0 plugged in here, 0 plugged in here. So trinomial form gives you the y-intercept right away. Boom. There is some work to do with the x. X-intercepts need a little bit of work. So what we do here is we make that whole equation equal to 0. And that's why we learn our factoring rules. We got to solve that. I think what I'm going to do first is, because we're actually just solving, right? How about if I multiply everything through by 4? Because I really don't like stuff in front of x squared that's not 1. If I can get rid of that right there, I'm going to multiply everything through by 4. 4 on this side, 4 on this side. So 0 times 4, still 0. 1/2 of 4 is gone, so it's just a 1. 4 times that's going to be 8, and that's going to be a 48. So question is this: factoring or quadratic formula? Which one do you guys want to do? Do you guys know any numbers that would multiply, give you negative 48, add to negative 8? Kind of really quick.
Negative 12 and 4.
Oh, that's cool. Yep. Negative 12, positive 4. And then, so that means each of those set equal to 0. I got myself a 12 and I got myself a negative 4. Man, a whole bunch of 12s and 4s and 16s around. Okay, so let's go over here. The x-intercepts are 12 and negative 4. So based upon this information, axis of symmetry, the vertex, y-intercept, and x-intercept. Can you give me a rough graph? A 25 is going to be very similar to this one. 21 is going to be a little bit of a more like a guess and check method, because you're going to multiply by 4 first. And so then you got to have a 4x squared in front. So then you got to figure out how you factor it down. Other than that, it should be good. Okay, so let's graph it here based upon this information. So I don't have to go into another page here. Let me see if I can just go ahead and graph it here. Obviously, you're not going to put every tick mark by 1. You're not going to say 1, 2, 3, 4, 5. It's just too big when you're going to get to 16. So maybe you could probably do it every 2 at this point. So 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And that's going to be my 20 over here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So negative 20 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, knowing that each one is worth 2. Okay, and from there, so then at that point, just let's plot some points here. So vertex 4, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Boom, right there. Hey, Charlie, good morning to you.
Did you get stuck in traffic?
Yep. No problem. We're just going over homework questions and yeah.
I know you stuck it.
Okay, vertex is there. We're just going over homework questions. 1, 2, 3, 4, 5, 6. There's my y-intercept. There's my x-intercept. 1, 2, 3, 4, 5, 6 times 2 makes 12. And the question is, do all the dots make sense? I think so. If this is the vertex, right? This dot makes sense as it's going to come up like this. And the y-intercept makes sense with the x-intercept as you bring things up like this. So, cool. If dot was off somewhere, then you're like, whoa, how does this work? No, this can't be it. So Dylan?
Yeah, the graph is not exactly.
Not, I mean, you don't have to do it by 2s if you don't like, but you should have a parabola that specifically hits this point here, specifically hits these points here. It should be going up on both sides. That's what you need. All right, we good. Cool. You guys tell me if I'm going too fast. Let's jam with it. 25, I'm gonna let you guys try 21. 49 is probably the other type, and let me just see. And then I'm gonna do 69 or 65, we'll see. I have to just do the tougher one. All right, jam to 49 here, number 49. it says, write the standard form of a parabola that has a vertex of -1/4, comma 3/2. Oh boy, that's no fun. And another point, just a point that it goes through, is -2, 0. So real quick here, talk to me, what is standard form? Ding, ding.
That'd be A, X minus H squared.
Perfect, This one's a nice one because it's already, we call it factor form, graphing form sometimes. Because it's really made for graphing here. Perfecto, I can plug in H and K right away. That's easy enough. That's gonna be X plus 1/4, because it's always the opposite for the H, and it's always just the exact same value for the K, based upon the formula of signs of minus signs and a positive sign. Boom. So notice the formula that we have. It's f of x is equal to all that. X is a variable. The only thing I don't know is A. I don't know how wide it's going to be or how steep it's going to be. That's my question. You could look at a graph and you can try to figure out by a graph by kind of moving off to the side once and going up. I don't think I want to do that with -1/4 and a 3/2. That's going to be a little bit too detailed for a graph. But let's talk about it here. If you go over here, guys, if I have this right here, just let me kind of make a function out of my own brain real quick here. If I have something like this, okay, and I say this guy goes through a point called 3, 5. No, sorry, 3, 7. I say this point goes through 3, 7. Where does the 3 come into the equation? Where does 7 come into the equation? Dylan?
3 would be x, and then 7, I'm pretty sure you could just replace f of x with 7.
Perfect. Yeah, that's technically the y value, and that's technically just going to be 7. So let's see if this works. Is that true? Perfect. Yeah. So that's the x value, and that's the f of x value. So that's x. This guy's either y or f of x, depending what you're talking about. If you're just talking about a graph in general or a function in particular. So that's what we're going to do here. We're going to take these values. So we're going to plug this guy in for x. We're going to plug this guy in for f of x. And that way, when you do that, you have one single variable left that you don't know, which is that little a value. So it just becomes a quick little algebra problem. All right, a little bit of work to do though. So let's see, got a little squared right here. So off to the side, you guys help me out here. What is -2 plus 1/4?
Negative.
I go with that. Common denominator would be a 4, so that changes into a -8/4. And A just said -7/4. That's fine. Let's do that. So 0 is equal to A. Again, the whole point here is just to find that darn A. Should be. Let me make the 7 look a little better. There it is. Talk to me. What should we do? I'm gonna pick on rows. How about that? Just pick on rows. I'll go what? 1, 2, 3, 4. So row 2, just to pick on you. What should you do next to solve for A? Either Landon or Dylan.
Would you subtract 3/2?
Absolutely. Subtract 3/2 off this one. Boom. Row 1. Next. Anybody from row 1?
You should know better.
Square both sides.
Not both sides, but just that one side.
Yeah, close enough.
49/16, I guess. And then to solve it, Camille, you can officially say you did math today.
No, I'm gonna get one.
These two cancel. This one right here is going to be a funny looking one. What is that? Negative. First of all, it's a negative. I know that. 16, 3 don't cancel. 49, negative 2 don't cancel. Okay. 49 times 3. Abe, is that the answer as well in the back of the book or not?
It has negative 24. Unless I read that wrong. Very confident.
Yeah, negative 20, negative 2. Just kind of check my math here. I think we were doing okay. I'm going to go with it here.
Is
Yeah.
the left side supposed to be multiplied by 49 over 16? Because that's, we're multiplying the other side by 16 over 49.
There it is. So how about, thank you. 16 on top, 49 on the bottom. Thank you so much. That helps a lot.
48 over 90.
This guy becomes a 1. That becomes an 8. Negative 24 over 49. And is that the answer? Sweet. Okay. Not done yet. One more thing to do. We got to actually write out our problem here. So f of x is equal to, there's my a value. My a value is that big giant thing. And then it's x plus 1/4 squared plus 3/2. And we got ourselves the solution or the equation. Where does this play out, guys? Economics, when we look at supply curves and called demand curves, we're trying to figure out where is that equilibrium point in order to get, let's say you own vast amount of apartment buildings, right? And so what you do is you figure out where the what's the demand for a certain product at a certain region, right? And then what's the supply? How much supply do you have? So those are going to influence. So you figure out what's the average rental price in that area, and you usually take about once a month or every 2 weeks. You check out what is the average price. So then you understand if the price is going to go down, then either your supply is going to go down as well, right? Or you can actually, if the supply goes up, there'll be less, if the supply is steady in the area, because your supply is, you don't have a whole bunch of different condos for rent or something. And so you can charge less, you can charge more. Farming does the same thing. Let's say you're a pistachio farmer. You look at how much supply there is technically in the world, and then you figure out what's going to be the selling price. What can you get away with as a selling price? But all depends on this. If you can actually make it into a formula based upon what throughout the year, based upon a certain supply that did not get filled, all the good stuff here. Okay, we're still jamming with homework questions here. One more. 65, 69. Abe, your choice. 65 or 69?
69.
Okay, that was Abe.
Yeah. There were 2 before them where my calculator isn't working right now. I can't.
Oh, you got that. Okay. Yeah. Okay.
I'm going to go with that one here, 69, and then says, I don't think you need a graphing calculator, do you? Find
No,
2.
The 2 before, and I was gonna say we're getting to do one, but it doesn't work right now, so I couldn't do the 2 before that. Use the graphic.
Oh, gotcha. Like 57 to 63.
Yeah.
Gotcha. You'll try it yourself, sort of thing, or you want me to do it?
For if you
Sorry, there's let's see, there's 57 for the homework, then there's 61 and 63. Right? Want me to do one of those?
No.
no, that's okay. We do 65.
Okay, yeah. Okay, we're good. Just want to make sure your homework questions are answered here. So find 2 quadratic functions, one whose opens upward and the other one that opens downward, whose graphs are given by these X-intercepts. So let's go for it here. So let me just draw it out. Let's see what happens here. So I have X-intercepts at 1, 2, 3. This graph goes here, and -1/2. There's another one right there. So notice real quick here is the fact that we have multiple parabolas that can fit into this. It could be that the parabola, don't draw this out with me here. Could be that the parabola is kind of fat, but it comes in very shallow. So it comes in like this, comes in like that, and then it comes out like that. We good? It could be that it's going to come in very steep. And if it comes in steep, it's going to go like this, and then turn back around and come back like this. We good? So multiple different ways we can, multiple different parabolas. What controls the steepness or the width of it? The A value, huh? That controls how steep it is, correct? So in this case, you're just going to plug in whatever A value you like. But we're just at least trying to get to this one. So then the question is, what turns it upside down? A value. Yeah, the A value being then the negative, right? So it says there's multiple answers to this, and the multiple answer is the fact that you can put in whatever you like for A. So put a positive in for A in order for it to go up, put a negative in for A to go down. And so what we're going to start off, we're going to usually start off like this. We put an A value over here, because you know it's going to be a multiplier. And because -3 is an answer, we have x plus 3 as a factor. And because -1/2 is an answer, we have x plus 1/2 as a factor as well. We good? Cool. And so what I'm going to do, I'm going to defoil all this out. Let's leave the A on the outside first still here, but this is going to be 1/2. Oh, that's fun. This will be a 1/2x. This would be 3x. And this would be 3/2 x. A little bit more. 1/2 plus 3. 3.5. Let's see. I think I want to. Yeah, inside an equation, we usually like to write it as improper fractions. Just looks nice. It's not everywhere. Okay, so there it is right there. So for the going up, I am just going to pick whatever I like for A. I'm going to pick a 2. Why am I picking 2? Just for the fun of it. That's it.
We don't like
Or
to.
because it's gonna multiply and really easily.
Oh, okay.
Daddy,
Or that. Yeah, there it is. I could have just picked a 3 or 4 or 5 or 6 or 7, right? Or a positive 1/3. That's fine. Whatever. As long as it was a positive 2. To go down, I'm just going to pick something that's negative. -3 I'm going to pick for. And that one's going to look funky. That's fine. So -3x squared. Let's see, -21 over 2x -9. Okay, we good there. So this piece is going to control. You guys get to pick that one, whatever you like.
7.
Or 7. You can pick 7 if you like. Okay, hey, we good? The homework questions answered? Okay. Yeah, you please tell them. Guys, I totally welcome homework questions. This is part of you guys learning the process, learning how to do it here. So,
The graph looks like an angry antelope.
give them teeth and stuff.
That's what I pay attention to. The angry antelope.
Jan, let's see where we at here. Okay, 2.1 homework done. Anybody have any 2.2 homework? Because we just first started it. Please come with homework questions for 2.2 on Friday. We'll handle those here. Okay, let's jam.
Who else would it be for you?
Now that I started to see.
So we are on to 2.3. So I think we probably will be able to finish it here. Oh yeah, so Polly.
I did actually. I did.
That was a fun year. It was not, it was so, well, I guess he's short.
Jelly fish with the mustache.
For real. I
I was sitting on and I dropped it and it shattered. How does it shatter?
Kind of, sort of not your fault.
Oh, move.
No, that was totally his
Literally
fault.
right there.
I'm still mad about
Get a
that.
better phone.
I think you got mad, you got me.
You got a better phone out of it.
No, I don't think I did. I think I got Michael's old phone. You got my phone like every 3 months. No, okay, I'm waiting till September to get the new ones and then I'll be fine. Right. Until the new one comes out.
Oh, no.
I'm not arguing because
It's
I don't know how
December.
to just take this.
So let's go for it, guys. We have, do you guys remember long division from 4th grade?
Oh my God, what's that?
That one?
See, wait, I don't
Cool.
know.
This is gonna be kind of like that.
No, that
So-
was so fun.
Let's do just a quick one here.
How come I'm the only one that likes long division and I'm the only one that actually hates math in this class?
Is it gonna be long?
I don't know.
Long division is
Oh,
so
long
fun.
division.
No.
Wait,
Yeah,
I'm
but
gonna
look at
go.
what
Did you guys, real quick, did you guys know there's something called short division too, right? Because there's long division, short division. So let's do this by long division and then see if anybody knows the short division method of doing it.
And then we usually should brain look at it and talk about it.
No, there's a small little short way of doing it here. So 5 goes into 483.
It's 96 and then I haven't got farther than that yet.
Wait, okay.
The rest of the classes.
Wow,
Hold on.
Camille, we just figured out Camille's
It's 96.
Secret power.
secret power, yeah, in division. So when you get this remainder of
It's
3,
96.6.
You added a 0.
hold on, we're not gonna go that way. We're gonna go with fractional answer for the remainder.
I know, I'm right.
96.
Yeah, but
6
anyway,
over
so-
time.
It's okay, I'll just go get a towel.
No, so it's 96 and 3.
Thank you, 3/5 is the answer. Okay, 96 and 3/5.
Question.
Teacher, staff, and students, may we have your attention, please? I repeat, attention, FLOCA, teachers, staff, and students.
Neil, it's an earthquake drill.
We are beginning our earthquake drill. I repeat.
Whoa.
I'm
Camille is dead. Camille, come inside. No, you're supposed to go underneath your desk. There it is. Just let it as much as you can.
Why did that? Limbo.
This is crowd.
Okay, wait, I thought we're supposed to stand in the doorway.
No. Doorways are considered dangerous as of 3 years ago.
Yeah, but if we learn enough, I wouldn't have time to get.
Because they know that we all.
This isn't meant to offend you, but you and I is in the doorway. I don't look anyone.
The reason why there's a 3/5 is because we get the remainder, bring it up on top, divided by our divisor, original
Yeah, but
divisor
that
there.
sounds like fractions, and I don't like fractions, so I'm just gonna stick with my 0.6.
Okay, stick with that, that's fine. All right, short division. You guys, short division, here it is. So what we do is you have to think of the subtraction in your mind. So you go like this, you go 9 here. Think to yourself, 9 times 5 is 45, subtracted 48, there'll be a remainder of 3. So what you do is you put a small little 3 right over here.
So it's the same thing, just less writing.
That's right, yeah. And then 5 goes into 33, and that little extra piece becomes the tens digit. So 5 into 33, 6 with it remaining. So there's short division. I still remember, I should have had it.
Never teach us this. Teach us
I
what?
don't know, short division?
Yeah, I never
Because
got
we
that.
want us to learn how to
So
do
you do
math.
realize there's
I
another
have been
step?
cheated of my entire life.
What?
See, no, I was just a bad student in 6th grade. I just always used the calculator when we weren't supposed to.
Okay,
Only in 6th grade?
let's jam. So here's what we do. Since we're in algebra, we go to this. We're just gonna say divide. And so we're gonna divide. The only thing is with algebra, we have variables on our hands. So we're gonna have to divide this. Divide 6x cubed
Oh, no.
minus 19x squared
I don't know.
minus 4
That's not
by
division. That's.
x minus 2.
Oh.
I gotta do it like that.
Hold on. Just to scare you.
So the, wait, no, you just factor the first
Oh, we just factored out 2x, right?
Hold on. No, we're not going to factor. We are going to long divide polynomials.
Oh,
So
factor.
let's go with
This
it
is
here.
why I don't pay attention. Hold up.
Maybe if we listen, they'll explain why we're doing
Could you,
it.
state the,
Just a thought.
Uh-huh.
Could you say what we're dividing again?
Yeah, we're dividing this right here. Let's see. I kind of,
Cube minus
yeah,
14.
I crouched it in there here. So plus
That's a
16x
Is that
minus
19?
4
Oh, boy. Never mind.
right there.
no.
Did you just ask for? a
Dylan,
cookie?
is that better? Sure.
Oh wait, I actually have a cookie in my purse if you want one.
Thanks, Camille.
Be polite.
Thanks, Camille. All right, let's go with it here. We're going to long divide this guy here. We're going to long divide a third degree polynomial by x minus 2. First things first is every single degree has to be represented. So the 3 has to come down, the 2 has to come down, x to the 1 power comes down, and your constant. And they have to be in order or else it doesn't work well.
Is there any way to simplify it?
Maybe.
No.
Isn't there like a way to split it into 2 parts and like hack that? But
Because
not for
no,
right here, but like
yeah.
in that thing.
Not really, because then you're mixing two things together. So let's go with it here. So what we're gonna do is we have two pieces here. We're gonna think about these two pieces here first in our minds. And the question is this: what multiplies this to get you this? What multiplies x to get you 6x cubed? 6x squared. This little 6x squared is gonna go right over here. Good there? So this is gonna be your x to the third column. This is gonna be your x squared column, x to the 1 column, and your constant column. We good?
A normal school hours, thank you.
You're welcome.
Okay. Yeah.
Runs to the phone.
Where did you just multiplied that by the x though? Where does the -2 go?
Yeah.
Yeah, we'll get to the -2 in just a second here. So we're dealing almost like this. Don't need to write it in, but we're kind of dealing with this little piece right here for now. And so x squared column is taken care of. And let's go with it. We're going to multiply 6x squared. And if you want to do it off to the side, that's fine. If you just want to do it in your head, that's fine. We're going to multiply that. 6x squared times x minus 2, which gives us 6x cubed. Everybody good there? Minus 12x squared. So notice all your cubes are lined up, all your squares are lined up. And what we're going to be doing is we're going to be subtracting.
Why
Tristan,
did we put the 6x on top?
how can we put it right here over here?
Now, where did that come
Because
from?
it's x squared, so it wasn't on the 19x squared.
No, I'm
Yeah.
I'm just confused where we got
Oh,
that.
sure, yeah. I'm gonna just let me rewind real quick here. Ready?
Yeah.
Rewind. So we're looking at this problem here. Our job is to figure out. Our job is to figure out what number multiplies this leading term. We call it the leading term to give you this leading term. So what number times x gives you 6x cubed? 6x squared. Are we good?
Okay.
So because it has a squared side, we're going to put it into the squared column.
But can you
And the
just
square.
go one term at a time?
We're going to go one term by leading term at a time, but then we're going to have to multiply by x minus 2 each time.
Okay.
So you're going to have two different things. And if you, so then let's go with it here. Boom. So this times this.
Is 6x cubed minus 12.
And this leading term right over here better be the same because that's what we're trying to go for in the first place, right?
Oh, wait, this is so cool.
Because we're going to have to subtract, and we subtract, these guys cancel. If they don't cancel, we did something wrong. Okay? Now, the only difficulty you have is this right here.
Still don't know what's going on.
So negative 19. Oh, hold on. Negative 19, subtract a negative 12. I don't like to be doing that all the time. Can I just do this? I'm going to change this to a plus, and I'm going to change the signs inside here all the time. Because then if I do that, then I can just be adding down, right? Or just combining up. Negative 19 plus a 12 makes
Negative 7.
negative 7x squared. And guess what? The next piece comes down just like division, and we start all over again. Question is, what multiplies x to give you a negative 7x squared? Negative 7x, perfect. I'm going to put into the x column right here.
Well, it works. It's just literally-
And negative 7x times x minus 2 is?
7x squared. Wait, no, times x minus 2 is 7x
Ooh, careful with the signs.
Negative 7x
Uh-huh.
plus 14. No, plus 14.
Awesome. Okay. So again, make it a little faster. You guys ready? So we're going to be subtracting, but in order for us to subtract faster, we're going to be adding the opposite. So we put that in there, and then we'll make this into a minus. We're good? Just makes it a lot easier than trying to think about subtracting negatives. So go ahead, guys. Ask me the questions here. Like, where did
How
the
can you just change the minus 12x squared to add 12x squared?
Oh, sure, yeah. So do you guys remember, technically what we're doing is this right here. We are, you guys remember this from Algebra 1? It's this subtracting this. So what you really are doing is you're just distributing the negative into here. The first one stays the same, no changes there. But notice what happens to the second parenthesis. That's what we just did. We just did it in a vertical way.
Does everything cancel out at the bottom, or did I do something?
I think everything should cancel out, yeah. So your leading term should cancel out, but you did something wrong for sure, right? 16 minus 14 is a 2x, and this guy comes down, minus 4. All right, x times what gives you a negative 2x, or 2x? 2. That, and then what you got to do is you got to put a plus 2 in here, plus 2, because the minus comes with the number, but the plus has to be in there. All right, 2 times x minus 2 is 2x minus 4. At this point, you can kind of see like, hey, those are the exact same things. I can just cancel both of them out, put a 0.
Oh, I thought I did it right.
If I do want to do it, then it's going to still be a 0 here.
Did you get the answer before the class?
Bam, you guys did some awesome
I got
division.
it correct.
That's cool. Good job, Camille.
I don't
That's
like it.
awesome.
So like, what's the whiteboard clean up?
No. Not with the cube root,
Why
with
do
the
I
square
not
root,
like
yeah.
that?
With the square root, it's all.
Are we gonna go over why this is like?
Yeah, but probably we're just setting it up now.
Yeah.
And then 2.4, we're going to deal with complex numbers.
It's very cool. I'm
And then we go
wondering
from there.
why it's a thing.
It's, I will tell you just a second here, yeah. Dylan, question? Guys, real quick here, let's begin. Dylan?
So we multiply we multiply the terms by just x, but then how come later on we multiply them by x minus 2?
We multiply them just by x?
Like the leading coefficient, like how we multiply,
You divide it by x, but then you multiply it by multiple x.
Yeah, the reason why we're kind of dividing by x is because this guy here was just x. So each time your leading term is going to be like 7x squared. Obviously, it's going to be 7x as your multiplier. If that leading term changes a bit, then yes, it's going to be a little different. We're good? If it was like a 2x minus 4, then it would have been different. Okay. Let's practice one more time with this here. Let's see if we go from there. Just the easy one here. This one's going to have a little remainder. That's okay. Exercise 2. Divide x squared plus 3x plus 5 by x plus 1. All yours. Again, very easy. You should be able to do it. It will have a remainder of 3 at the end. We're going to leave them there for now. And so let's see, just like we did long division, the first problem we did from pre-algebra, we're going to write it as a fraction. So, yeah. After we do this one, I'll tell you how factoring works then in this process.
You said there's a remainder of 3, right?
Remainder of 3. All right, let me do it off to the side here. You guys look up when you're done, or look up if you want to just get some extra help here. So I want to make sure that all of them come down in order. x times x gives me x squared. Perfect. X times x is x squared as I wanted. X times 1 is just x or plus x. I subtract. Instead of subtracting, I'm going to add opposites here. So minus sign here, minus sign here. First leading term should cancel or else I did something wrong. 3 minus 1 is technically a 2. 5 comes down. And the process starts all over again. X plus 2 or times 2 gives you 2x. 2x plus 2. Subtract. Or instead of subtracting, add the opposite remainder 3. Awesome. Okay, so let's bring this down. So the answer to this guy is x plus 2, because that's coming from over here, plus 3 over x plus 1. There's my final answer. So now let's connect a whole bunch of pieces together. We good?
Oh. Wait, why is it 3 over?
Yeah, because this is our divisor.
So, for the remainder, you just put it on top of it.
Yeah.
That's how you do it.
So let's go back to yeah, guys, let's put a whole bunch of stuff together. Like this right here. Talk to me. See if this makes sense. This guy here, isn't this the same thing as 90 plus 6 plus 3/5?
Yeah.
Yeah, so in pre-algebra, when we were doing this stuff, I know we put numbers together tightly, right? Because unit values are there. But really, essentially what we're doing is we're doing the same thing here. We're saying, okay, look, there's 9 tens, there is 6 units, and there is 3 pieces of 5. We're good? And so the other thing that we should notice is this right here. Whenever you divide something, right? So let's go back over here. Let's put this together. 3 goes into 12 4 times, is that right? If you have a remainder of 0, what that means is 12 is equal to 3 times 4, is that right? So let's go back and do the same thing here. The answer to this one is 6x squared minus 7. That's the answer, right? But let's go a little bit further. So I just found this out. Tell me if you guys agree. That's 6x cubed minus 19x squared plus 16x minus 4 is equal to, oh, I had a remainder of 0, is that right? That means the answer is x minus 2, 6x squared minus 7x plus 12. Let that sink in just for a little bit.
So this is a factor way to factor cube.
This is a way to factor if possible, but if not, we still get the multiplier. So if there's no remainder, notice right here, there's no remainder, we have factored this degree 3 polynomial down. If there is a remainder, that means we still were able to divide it, but we also know that it was not factorable. X plus 1, right? X plus 2, if it's like this, right? That's what we got, right? That means it is not factorable at the end. In fact, it's more like, sorry, I should write it like this here. That's a question, because the remainder is just the remainder. It's this plus this. So whenever you get remainders, let's go with it this way here. 3 into 11. That's going to be, or 3 into, actually, I should say like 14. Does 3 go into 14? No, right? Not directly, right? But it does do this. But then if I know that I have a remainder on my hands, I know 3 and 4 don't multiply to give me that. So it's a way to find out if it's factorable into a problem as well. Okay, let's see, we only have a little bit of time. Let me jump to this one and we'll finish off on Friday with this one. How about this exercise? Now this one you could have done by factoring here. That's fine, but we're gonna do it by long division. This is just to give us this little piece right here. X cubed minus 1 by x minus 1. I'm gonna show you a little something here.
So where do you put the x cubed?
Wait, does that say X?
It says x cubed minus 1.
Where do you put the x?
So now, remember how we have to have columns, right? We have to have the x squared column, we have to have the x column, where we're actually missing 2 columns. So what we do off to the side, we go x minus 1 on the outside still. On the inside, we're gonna go with x cubed plus What number can I plug in here that is technically not adding anything at all?
0.
Yes, there it is, 0x squared plus 0x minus 1. There it is. Now I have all the degrees. All of them have spaces, and all of them have columns for themselves. If you're ready for it, go for it. I'm going to start it as well. So x times what gives you x cubed? That'll be x squared. I'm going to put in my x squared column. X times x is x cubed. X squared times a negative 1 is negative x squared. Okay. I'm going to subtract. Better yet, add the opposite. First, better go away. Oh, 0 plus 1 is just, I have an x squared remaining. So bring down the other one. X times what gives you x squared? X or plus x. Whenever it's positive, we have to put the little plus sign into it. X times x is x squared. X times a negative 1 is negative x again. Subtract. Better yet, add the opposite. Leading term better cancel, or else we did something wrong. And then we have x. Oh, boom, this comes down. And what do you guys say?
1.
Just a 1 plus 1. Boom. X minus 1. Ooh, 0 remaining. So therefore, could x minus 1 divide into x cubed minus 1? Yeah, it would have divided perfectly. It would have factored the term. So the answer to this guy, for the homework question, the answer is this right here, and you're done. But I want you just to realize this is true. That is true right there. We good? All right, we'll move on with a little bit of long division on Friday, and then we're going to hit something called synthetic division. Whoa, whatever that is. See you. Got it.